There are 7.3-liter PowerStroke engines with 400,000 miles on them right now, pulling loads on ranches and job sites that have never been opened. The engine Ford replaced them with in 2003 was destroying connecting rods at 30,000 miles. If you already know which engine you trust, if the build date in your head falls before October 2002, what follows is the specific story of how Washington made that choice for millions of Super Duty owners who had no idea it was being made. In the winter of 2003, across Ford dealerships from Michigan to Texas, service departments were logging the same failure on brand new F-250 and F-350 Super Duty trucks. The EGR cooler, the emissions hardware mandated by federal regulation, was cracking internally. Coolant was crossing into the exhaust stream. On trucks that sat overnight, that coolant drained by gravity through an open exhaust valve and into the cylinder beneath it. When the owner turned the key the next morning, the starter spun, the crankshaft turned, and a liquid-filled cylinder met a connecting rod that had nowhere to go. The rod bent. The engine was done. Truck owners with 30,000 miles on new Super Duties were filing warranty claims on trucks that still had 2 years of payments left. The failure would repeat across the Super Duty population in nearly identical circumstances for the next 4 years. 6 months before those first failures appeared, Ford had assembled the last 7.3-liter PowerStroke at the Windsor engine plant in Ontario, Canada. An engine that routinely reached 400,000 miles on individual trucks without ever being opened was ending its production run. Not because it failed the people who owned it, but because the federal government had made it impossible to continue selling it. What most people do not know is the specific date Washington made that decision and what the engineers at Navistar were not given enough time to finish before it happened. On October 22, 1998, the United States Department of Justice and the Environmental Protection Agency held a press conference and announced the largest Clean Air Act enforcement action in American history. 7 companies controlled 95% of the American heavy-duty diesel engine market. The settlement included an $83.4 million civil penalty, the largest environmental fine in United States history at that point, and a mandatory commitment of more than $1 billion in compliance spending. Attorney General Janet Reno told the country that the diesel engine industry had illegally poured millions of tons of pollution into the air. The 7 companies named were Caterpillar, Cummins, Detroit Diesel, Mack Trucks, Navistar International, Renault, and Volvo Truck. Since the early 1990s, these manufacturers had programmed their engine computers to behave differently during Environmental Protection Agency testing than during actual highway operation. During the Environmental Protection Agency's controlled 20-minute federal test procedure, the engines were clean. While cruising on the highway at a steady speed, which is the operating mode that represents the majority of a working truck's life, those same engines produced up to 3 times the legal limit of nitrogen oxide. Why would manufacturers who built engines for a living program them to run one way on a government dyno and another way on the road? And what was the EPA doing while it happened? Margot Oge is director of the Office of Mobile Sources at the EPA, and she described the mechanism. She explained that the computer system senses timing and other things like speed and temperature, so that as long as you are under conditions similar to the federal test procedure, you are fine, but otherwise, nitrogen oxides double or triple. The manufacturers never admitted guilt. They signed the consent decrees because the alternative was losing their certification to sell engines in the United States. Jim Henderson, the chairman of Cummins Engine Company, stated the decision plainly. The company settled to avoid protracted and expensive litigation. Stephen Homcha, vice president of engineering and product planning at Mack Trucks, described the negotiation to transport topics in different terms. They held a gun to our head by threatening to withhold certification for 1999. He said the EPA's conduct bordered on a crime. The $83.4 million fine was not the consequence that broke the engineering programs. The penalty that did the real damage was buried in the consent decree text. Every signatory was required to meet the 2004 EPA emissions standard by October 2002, a full 15 months ahead of schedule. Industry estimates at the time put the cost of that compressed timeline at approximately $820 million. The engineers inside these companies understood that the real cost was not measured in dollars, it was measured in the months of bench testing, validation miles, and thermal cycling data they would not accumulate before their engines went into production trucks. But what did $820 million actually buy, and what is the one input? No budget on Earth can purchase once a federal deadline has been fixed. Navistar International had been building diesel engines for Ford's pickup trucks since 1983. The 6.9-liter indirect injection diesel in the original F250 and F350 was a Navistar product. Its pre-chamber design produced smooth combustion, and it carried a significant thermal efficiency penalty in the process. The 7.3-liter indirect injection engine that replaced it in 1988 used the same architecture at greater displacement. Neither engine, in early naturally aspirated form, produced the sustained torque output that would define diesel pickups through the 1990s. When Ford and Navistar introduced the 7.3-liter PowerStroke turbodiesel in 1994, it used direct injection, a turbocharger, and an intercooler, and a fundamentally different injection architecture. They built something without an equivalent in the American pickup truck market. The PowerStroke used hydraulically actuated electronic unit injection, known as HEUI. International had co-developed the HEUI system with Caterpillar, and the architecture had been proven in medium-duty commercial applications before it appeared under the hood of an F-Series pickup. The engine's lubrication circuit was pressurized to between 500 and 3,000 pounds per square inch, depending on load, and it actuated each fuel injector individually. There was no common high-pressure fuel rail. There was no injection pump distributing fuel into a shared network under continuous pressure. Each injector drew its actuation force from the oil system at its own cylinder, responding to the actual hydraulic pressure at that moment under that specific load. The practical result was that each cylinder's injection event was mechanically independent. A failure in one injector circuit did not cascade to the others. A mechanic who understands hydraulic systems and basic electronics could diagnose any 7.3-liter problem without a dealer laptop because the engine communicated its failures through the same physical systems it used to do its work. That relationship between machine and mechanic, the ability to look at a failure, name it, and fix it without requesting authorization from a dealer network is not a small thing when the truck is also the business. What was it about this architecture and the decade Navistar spent refining it in production that produced engines capable of 400,000 miles on original internals, while the replacement built on a federal timeline fell apart at 40,000? By 2001, the PowerStroke in its final 275 horsepower, 525 pound-feet specification was logging 200,000-mile service records on work trucks that had never been opened. There were documented cases of individual 7.3-liter engines crossing 500,000 miles on original pistons and liners. The number circulates through diesel shops the way certain football scores circulate through a bar, repeated, disputed, and ultimately confirmed by enough first-hand accounts that disputing it becomes a waste of time. The architecture was not exotic, and the manufacturing process was nothing unusual. What the 7.3-liter had was the one thing the consent decree could not extend: time to fail in testing before failing in the field, and time to accumulate the engineering revisions such as better high-pressure oil pump drive gear, metallurgy, repositioned injection control pressure sensors, and revised-up pipe material specifications, changes that turned early production vulnerabilities into known service items with documented repair procedures. What does an engineering program look like when the people running it are given enough time, and what does it produce when Washington cuts that time short by 15 months? The October 2002 deadline took that accumulation away from the engine that was supposed to follow the 7.3-liter. The engine Navistar brought to Ford to meet the accelerated consent decree schedule was internally designated VT365. Ford badged it the 6-liter PowerStroke. It launched in late 2002 for the 2003 model year, replacing the 7.3-liter across the F250, F350, and E-Series lineup. On paper, it was the stronger engine, 325 horsepower compared to 275 for the 7.3-liter, 570 pound-feet of torque. A variable geometry turbocharger improved response across the RPM range, 4 valves per cylinder instead of 2. The EGR system, the emissions hardware the consent decree had pulled forward by 15 months, routed a portion of exhaust gas through a compact heat exchanger mounted beneath the intake manifold, reduced its temperature, and fed it back into the combustion chamber to limit peak nitrogen oxides formation. The cooler was a shell and tube design. Hot exhaust entered one end at temperatures exceeding 1000 degrees Fahrenheit. Engine coolant at approximately 200 degrees Fahrenheit circulated around the tube bundle. The gas exited the cooler. Its failure point was the weld interface between the individual exchanger tubes and the header plate at each end of the cooler body. Every heat cycle, every cold start, every loaded climb, every overnight shutdown imposed a thermal gradient across that weld interface that expanded and contracted the metal at the joint. The factory EGR cooler was not designed to absorb that cycling indefinitely. Testimony in a 2017 federal lawsuit against Navistar established that the cooler's actual service life, based on testing conducted before the engine entered production, was less than 20% of the stated design requirement. What did the engineers who reviewed those results already understand about the cooler's limitations, and what did it take for the people making payments on new Super Duties to find out? The former senior vice president of North American sales for Navistar testified under oath about the development program. His exact words, entered into the Tennessee federal court record, described the testing process in terms that a YouTube channel cannot broadcast without a warning card. By February 2007, Ford's internal documents showed warranty repair costs on the 6.0-liter had exceeded $400 million, the highest repair rate of any engine in Ford Motor Company history. The 6.0-liter represented 10% of Ford's total engine volume, and it was generating 80% of Ford's total engine warranty spending. Ford filed suit against Navistar in January 2007. Total warranty and recall costs to Ford reached approximately $1 billion before the engine's production run ended. Ford settled a class action brought by Super Duty owners in October 2013, reimbursing a percentage of costs for EGR coolers, EGR valves, oil coolers, fuel injectors, and turbochargers that had failed before 135,000 miles. The complete list of failed components reads like a bill of materials for everything the 15-month compression never had time to validate. The 7.3-liter was not a flawless engine, and saying so is not a concession. It is the distinction that makes the argument here worth following. Early PowerStrokes, from 1994 through approximately 1997, had a documented problem with the high-pressure oil pump drive gear. The gear could develop stress fractures under sustained load that progressed without external indication until the gear shattered and the pump failed without warning. ICP sensors on those early pumps were mounted in a location that exposed them to excessive heat and oil contamination, shortening service life unpredictably. The turbo up pipe, the cast iron section between the exhaust manifold and the turbocharger inlet, cracked in cold climates from years of thermal cycling. Exhaust leaked at the fracture. Boost dropped. Owners noticed the loss pulling a grade or caught exhaust odor in the cab at low idle. Every one of these failures had a specific location, a documented cause, and a repair a working mechanic could complete with off-the-shelf parts in a known amount of time. What separates a failure mode you can schedule and budget for from one that finds you in a cold parking lot on a truck with a financing balance and no warning that anything was wrong? When the 6.0 liters EGR cooler cracked internally and coolant entered the exhaust stream in volume, the truck might sit overnight. That coolant could drain past an open exhaust valve into the cylinder beneath it. When the owner turned the key the next morning, the first indication of a problem was that the engine would not rotate. The dash showed nothing. There was no warning light, no code, no gradual loss of power that would have sent the owner to a service department before the engine failed. The 7.3 liters known failure modes could be diagnosed, budgeted, and repaired on a schedule the owner controlled. The 6.0 liters primary failure arrived without announcement on trucks with full financing balances and left repair estimates that on older examples exceeded the vehicle's market value. Ford ended its relationship with Navistar after the 6.0 liter and developed the 6.7 liter PowerStroke entirely in-house. That engine launched in 2011. It is a more capable diesel truck engine than the 6.0 liter. Not because Ford's engineers in 2008 were more talented than Navistar's in 2002, but because the 6.7 liter was developed on an engineering timeline rather than a federal compliance calendar. The 7.3 liter PowerStroke remains the benchmark, not as a collector item or a garage restoration, as a working machine attached to a load. There is a 1999 F250 somewhere in eastern Wyoming right now, sitting in front of a carving shed with more than 370,000 miles on the original PowerStroke block, maintained by a man who has never paid for a dealer diagnostic session. That truck runs because the engineers who built it were given enough time to understand where it would break before it was sent to work. Every working mechanic who has driven a pre-emissions diesel to a job site understands this in a language that does not require explanation. The October 2002 deadline took that time away from the engine that followed. The document that set that deadline was filed in a federal courthouse in Washington, D.C., by people who had no reason to think about what a connecting rod does when coolant fills the cylinder above it overnight. Washington measured the problem in nitrogen oxides, 1.3 million tons of excess from 1.3 million engines in a single year. The Super Duty owner measured the same decision in a bent rod on a truck with 38,000 miles and a payment due on the 1st. If the engine you would choose is already clear in your head, if the build date you trust falls before October 2002, that preference is not sentiment. It is what happens when the deadline belongs to the regulator and the consequences belong to the person who turns the key.